Hi everyone, in this video we are going to discuss about theorem number 22 from the geometry of circles. Here the theorem says angle between two intersecting chords, angle AED, is equal to half of the sum of the central angle of BC arc and the central angle of AD arc. Let's suppose you have a circle like this as you see in the diagram with center at the point O, and we have two chords there, chord AB and chord CD. They intersect each other at point E, and here we have to calculate the angle between them. For example, the angle AED, that will be equal to half of the sum of the central angle of BC arc and the central angle of AD arc. That's what we have to prove. The central angle of the BC arc would look like this. It will be the angle BOC, and similarly the central angle of the AD arc will look like this. It will be the angle AOD. So here the notation, the BC with a little arc sign on top of it, that notation actually indicates that the central angle subtended by the BC arc, and that is actually the angle BOC, and then the central angle subtended by the AD arc, that is actually the angle AOD. And we have to prove that the angle AED will be equal to half of the sum of those two central angles. In order to do the proof, I have to do one more construction here. I am going to join B with D. And then let's take a look at the triangle BDE. In this triangle, if we look at the angle EBD, that will be half of the central angle AOD. We have already seen in an earlier theorem that inscribed angle is half the size of the central angle. So in this case, angle EBD will be half of AOD, and the angle AOD can be denoted as AD with that arc sign on top of it. And similarly, if we look at the angle BDE, that will be half of the central angle BOC, because BDE is actually the inscribed angle for the arc BC, so that will be equal to half of the central angle BOC, and angle BOC can be denoted by BC with that arc sign on top of it. Now let's take a look at the angle AED. AED is actually an exterior angle of the triangle BDE, and AED will be equal to the sum of the two farthest interior angles of the triangle. So then we can say that angle AED will be equal to angle BDE plus the angle EBD. Now here let's replace the value of the angle BDE and the angle EBD. So in place of angle BDE, I can say this is half times BC with that arc sign, plus in place of EBD, I can write half times AD with the arc sign on top of it. So if we simplify this, we can write it as half times BC with the arc symbol and plus AD with the arc symbol. BC with the arc symbol indicates the central angle subtended by the arc BC, and AD with the arc symbol indicates the central angle subtended by the arc AD. And this is exactly what we needed to prove for this theorem. So in a problem, if we have been provided with the central angles of the arc AD and arc BC, we can easily calculate the value of the angle AED, and that will be half of the sum of the two central angles. This is also a very interesting property of circle. Please make a note of it. I hope the proof made sense. Thank you for watching. See you in the next video.